Okay, in problem 16, we have a variable to a power equals a number. So looking here, that looks like that represents a type 1 problem. You have a variable to a power equals a number. So we're going to bring the power over to the other side by doing the reciprocal power. So this is x equals 27 to the 4/3 power, which gets you x equals, this is the cubed root of 27, which is 3 to the 4th power, which gets you 81. Okay. On 17, looks like this is very similar to 16. The only difference here is we have some extra information here, so we're going to need to get this so it's just a variable to a power equals a number. So we're going to bring the 5 to the other side, so you get negative x to the 1/3 equals negative 1. Then when you're going to bring the divide both sides or multiply both sides by negative 1, so x to the 1/3 equals positive 1. And then x will equal 1. Do the reciprocal power. That's 3, or 3 over 1. So x equals 1. Okay. Now number 18. Here, we start off with a log. So if we start off with a log, looks like that's a type 3 problem where you have a log, which is a base and answer of power. So you want your base, your answer, your power. Here, the base is 10. So this is 10 to the power of 1 equals 3x. So then you get x by itself, divide by 3. So x equals 10/3. Okay. Okay, let's look at number 19. Number 19. Looks like we have logs in our problem. Well, if we look at type 1 problems don't use logs at all. Type 2 problems, the original problem doesn't have a log in it, so not a type 2 problem. Type 3 problems start off with a log, where we have logs. Problem is we don't have one log, so we'd like to take this and turn it into one log. Well, that's why we spent the time combining logs. So we need to get the number up to the power. This one doesn't have a number, so this is log x to the 3rd minus log 2x equals 2. Now, since this is subtraction, we divide this value and this value, so this is log of x to the 3rd over 2x equals 2. So now we're down to one log. Our base, little subscript, wasn't there, makes it a 10. So now we're going to follow type 3 problem here. Type 3 problem, we've got our base, our answer, our power, so we're going to BAP it. So this is 10 to the power of 2 equals x to the 3rd over 2x. Okay. So now we've got that set up. Now this, we could actually reduce this fraction. So 10 squared is 100 equals, this x cancels with one of those, so this is actually x squared over 2. So then we can bring the 2 over. So that gets you 200 equals x squared. Get rid of the squared by square rooting. So this is the square root of 200 equals x. Okay. And technically it should be plus or minus, but you can't take the log of a negative, so we just have the positive value there. Okay. Let's do one more in this video. So here, number 21. Looks like we have a number, which is e. E is a number, to a variable power equals 12. So we look, type 1 problem would be a variable to a numeric power. That's not what we have here, our variables in our power. So if we look at type 2 is where you have a number to a variable power. So this is actually a type 2 problem. So here we're going to switch to log, but because our base is e, we're going to use ln. So this is natural log. Your base is e, which you don't need to write, but you can. Your answer, we need answer, which is 12, equals your power, which is 3x. So natural log of 12 is just the number, which our calculator is going to give us. And the net has to get divided by 3. So this is natural log of 12 divided by 3 equals x. So let me show you how to enter that in the calculator. So this is natural log second ln. Oops, sorry. Don't need that. Just hit ln. Natural log 12, close your parentheses, divided by 3 gets you approximately, so this is x is approximately equal to 0.828. Okay. So those are the first few. We'll do the next set in the next video.